Yesterday we used the law of sines to help us solve triangles, and we could use the law of sines when we had a triangle, in any triangle, not just right triangles, and we could make two loops where we knew angle B and side B, and we knew either side A or angle A. We could use the law of sines to figure that out, or if we knew angle C or side C. But we needed to know one complete set. We needed to know an opposite side and that corresponding angle. And then from there, if we knew any one piece of other information, we were able to solve the triangle. Now, the law of cosines, what that states is that it's kind of like the Pythagorean theorem, but you don't need to be able to make one complete loop with both sets of information. So you'll notice that maybe this is a one. Let's look at c squared equals a squared plus b squared minus 2ab times the cosine of c. This you guys know as the Pythagorean theorem. C squared equals a squared plus b squared. It's this extra stuff here that makes it the law of cosines. And remember, the lettering really doesn't matter, but something you need to pay attention to is that, a squared, that side squared, and you need to know the angle A. Or side B, you need to know angle B. And then side C, you need to know angle C. So I do this with loops again and say if you know two sides and the angle in between the two sides, then you could use the law of cosines. Or if you know all three sides, then you could use the law of cosines and solve for one of the angles. So this helps you. The law of cosines allows you to solve when you know all three sides, or you know two sides and the angle formed between the two sides. So let's look at example number 1, and we have a picture drawn. I know angle B is 26 degrees. I don't know side B, so I'm going to make a loop there. So that's one loop. And I know the two sides that form that angle. So I'm going to have to use the law of cosines first to find side B. Once I've done the law of cosines, I could go back and do law of sines like we did yesterday, or do law of cosines again. I think law of sines is easier, so I'm going to do that instead. So law of cosines, notice that I know angle B, so up here, I'm going to be using this one because I know what angle B is. So this is going to be b squared equals a squared plus c squared minus 2ac times the cosine of b. And then we can substitute. So b squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 26. Now the beautiful thing is that we can just type this into our calculator if we are in degree mode. So let's double check. Turn the calculator on. I am in radians, so let's go to degree instead. So 7 squared plus 12 squared minus 2 times 7 times 12 times the cosine of 26. So 42. So b squared equals 42. And then when we square root both sides, the square root of 42, is 6.48. So b is equal to 6.48. Okay, so now we have found that side B is 6.48. We can use law of sines to find the other side, and I like law of sines better because it's a quicker calculation. So I'm going to pair these up. So 6.48 over the sine of 26 degrees. Now over here, I did write that if you're going to use the law of sines, you must find the smallest angle next. So going back over here, how do you say, well, is angle A or angle C going to be smaller? And you can't just go by the picture, you got to go by the side lengths. Angle C will be bigger because it's across from the bigger side than, angle A is across from 7. So we have to do 7 over the sine of angle A. If you do it in reverse, if you find C first, you're going to end up with the wrong answer at the very end. Your angle A could be the largest angle, which it can't be because it's not across from the largest side. So then we'll cross multiply. 7 times the sine of 26 degrees equals 6.48 times the sine of angle A. I'm going to do this division first in my calculator and then do the inverse sign because I want the most exact answer. So 7 times sine of 26, close parentheses, divided by 6.48. You must remember to close those parentheses. And we get 0.473, so 0.47. That's not the angle measurement, that's what the sine is. So then we will do the inverse sine, of 0.47. And that gives us 28.03 degrees. 28.03 degrees. So now that we know two angles, we can calculate the third one by doing 180 minus 28.03 minus 26, and that will give us our last angle. So 180 minus 28.03 minus 26. Oops, I forgot the minus button back here. And that's 125.97. 125.97 degrees. So the measure of angle C is 125.97 degrees. Now you could, if you're going to use the law of cosines, when I use the law of sines, you must find the larger one next. The reason for that is because we know that the inverse trig functions gives us the reference angles for when we do the law of sines, so that's why we want to find the smallest one next. So now we have solved the triangle. We know angle A, C, and we calculated side B, and we were given the other three pieces of information. Now on to the next page, you see that we have three sides and I'm missing and no angles at all. So we have to use the law of cosines because we don't know any of the angles. You want to always find the biggest angle first when you're using the law of cosines. So since this side here, AC, is 13 across angle B, that's the biggest side, AC. So I'm just going to label those sides across from the corresponding angles. So now we we will set up the law of cosines, but we're trying to find an angle this time, so we can't just throw it all in the calculator. So b squared equals a squared plus c squared minus 2ac times the cosine of b. So 13 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of b. Well, 13 squared is 169. 49 plus 81 minus 2 times 7 times 9. We can put that part in the calculator. And that's going to give us 126 times the cosine of b. So 49 plus 81 is 130. So 169 equals 130 minus 126 times the cosine of b. Subtract 130 from both sides. And that's going to give us positive 39. So 39 equals negative 126 times the cosine of b. Divide both sides by negative 126. So we're trying to get this cosine of b by itself here. And we get negative 0.309 or negative 0.31 equals the cosine of b. So then to calculate the angle is going to be the inverse cosine of 0.31, negative 0.31. Inverse cosine negative 0.31. And that gives 108.06. So we know the biggest angle here is 108.06. Now I want to use the law of sines. And when I use the law of sines, I need to find angle A first because that's the side that's opposite the shortest, or sorry, that's the angle that's opposite the shortest side. So we're going to do 13 over sine of 108.06 equals 7 over the sine of A. And then we'll cross multiply like we did on the previous problem. So we get 7 times the sine of 108.06 equals 13 times the sine of A. Divide both sides by 13. So then in the calculator, 7 times the sine of 108.06 divided by 13, that's 0.511. 0.51. So 0.51 equals sine of A. So then we will do the inverse sine. Of 0.51 0.51, and we get 30.66 degrees. All right, now that we have two angles, we can calculate the third one. So 180 minus 108.06 minus 30.66. That will give us our remaining angle. So 180 minus 108.06 minus 30.66, and we get 41.28. So the measure of angle C is 41.28 degrees. So we found our missing pieces of information. Angle B was 108.06. Angle A was 30.66, and angle C was 41.28. So those would be my three angle measurements, and we already know these three sides from the original problem, so we've solved this triangle. So yeah, these problems can be very tedious. There's a lot of work and a lot of algebra. Like, we're not doing anything that advanced right now. We're taking a formula and we're plugging stuff in, and then we're solving for one of the variables. So your algebra manipulation skills have to be very good. Like, this is where most students will struggle, is this law of cosine stuff, where we have to get this part by itself. So the problem below, I'm going to have you guys try. It is just like the one up above, where you have three sides. Let's draw the picture together. Okay. Little a is 23, so the side across from a. Little b is 18, and little c is 20. Okay, so when you're doing the law of cosines, you're going to find angle A first. You're going to find um, this angle and then find the other ones, just like what we did up here. So the law of cosines formula you're going to use is a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. So I'm going to ask you to pause the video, try this, and what I suggest doing is, like, after you do the law of cosines part, unpause the video and just check this part, so that way you can see if you got this right before you use this information to get the other parts. Usually I would say that we don't want to use calculated information to get the next part of the problem in case we calculated wrong, but we don't have an option with these problems. So I would pause it after each step and see if you're still on the right track. All right, so you can look at my answers here, double check them, and hopefully you did stop after each step and saw that and unpause it and saw that angle A was 74.34 degrees, and then use that information to get angle B and then angle C. So again, these problems do take some time, so slow down, be careful. We only did 3 of them today because they do take that long and they do take that much attention. So if you need to refresh something, absolutely go back and refresh yourself on it. So thanks for watching. Make sure to like the video and subscribe.